Hello everyone, my name is Luca Babetto, I work in Cineca, and today I will, alongside my former colleague Andrea Proia, talk to you about Vectoria, the service that we have developed for EuroCC Italy that enables everyone from small and medium enterprises to large companies to deploy their own private AI chatbot for internal documentation. First of all, a quick word about our partners for the Italian NCC. I'm here representing Cineca. We we're an HPC center, and we host the Leonardo supercomputer that to this day is still the 10th in the 10th position in the top 500 list. We have collaborated on this specific project with Leonardo SPA, a company dedicated to aerospace, defense, and cybersecurity, and who have sponsored the scholarship that Andrea has used to help us develop this project. We also work with Domper Pharmaceuticals, another company, a large company invested in research for HPC and AI on the pharmaceutical side. And also IFAB and Birex, there are two companies that are helping us, especially with the training and dissemination for technology transfer for small and medium enterprises, especially. So as of today, I will let Andrea talk about the specifics of Vectoria, as he was actually the main developer, one of the main developers of this project. He will talk briefly about LLM fine-tuning and RAG, which is a technology that we have implemented in Vectoria, and explain a bit about the Vectoria workflow specifically. Then I will show a brief use case on some answers that use different LLMs and how they compare to each other, and finally a brief showcase on how to actually deploy this system and to show you how easy and simple it can be. Okay, I'll leave the floor now to Andrea.
Okay, so hi everyone, and thanks Luca for the introduction. So let's go with the agenda, but before starting with explaining what actually Vectoria is, so a retrieval augmented generation pipeline, why we may need this kind of technology, we first need to understand a bit of a comparison with a fine-tuning operation, which I'm sure you know, which may be a solution in case you want to specialize your LLM on your private specific documentation. So let's say we want to specialize our model with our private document. What we may do is to perform a fine-tuning operation, which is just an additional training step that we do on top of a already pre-trained large language model that we can download open source from the web. And by doing so, we are injecting actually the knowledge inside our documents inside the parameter of the neural network. So we are updating those parameters to obtain a specialized model. Instead, the RAG technology, which is exactly this slide, is a technique for retrieving relevant information from an external source, because the fine-tuning operation, sometimes may have some high related costs in terms of computational power and also money. So a RAG pipeline may help us in avoiding these costs. So in this case, we are not injecting anything inside the large language model, so the model remains untouched, but we are just attaching an external source, an external knowledge base to the LLM, and we use this information, parts of this external knowledge base, as input along with the query to help the LLM to answer to the user question. Let's see in the next slide a direct comparison between the fine-tuning and the RAG operation to see why we decided to use this kind of technology. So on one side we have the fine-tuning operation, which as a pro, as that it gives us a specialized model, which is totally fine. but it also carries high computational cost from the point of view of the power that we need to do such operation. And most importantly, this operation must be repeated every time the documentation changes, because if we want to update with further documentation, we need to perform an additional fine-tuning operation. And also we need usually a quite big and high quality dataset to perform this operation in the correct manner. On the other side, the RAG does not give us a specialized model, but we still rely on a general purpose model that we can download open source. But this is totally fine because we are injecting the knowledge using our ecosystem. So we are helping the generic purpose model. But the pros are that we contain the computational cost because we don't need to perform any training step on the LLM. We can modify the documentation as many times as we want, because we can just attach different knowledge bases to our LLM as we need. And also, this is an important part, we reduce the probability of hallucination, which is a phenomenon that, you know, it may happen with the LLMs, because since they are just autoregressive models, they produce the next most probable token in a sequence. And so sometimes they tend to produce fake answers that are not grounded with our actual documentation. So in the next slide, we start looking at the first of the two workflows that we have inside Vectoria, and actually inside any RAG system. The first one is the index creation. So we have our documents and we want to obtain the external knowledge base that we mentioned before. So we start with the documents. We need to clean them in order to remove all the noise and to have just the information inside the actual content of the document. And then we need to split them into manageable portions of text, which are called chunks. Each of these chunks, the blue ones that you see, is then embedded. This operation is done by a specific kind of neural network, which is called an embedder, as you can imagine. And this network just converts this portion of text into a vector of float numbers with a fixed size that should, how can I say, should represent the information inside the text of each chunk. So we have a one-to-one correspondence between a textual chunk and its embedding, which is a vector of number. Each of these vector is then stored inside a vector database, which is a specific kind of vector that is used for the second workflow to perform the similarity search. Yeah, and here we have how we actually answer to the user query using the retrieval and the generation part. This is why we have a retrieval augmented generation as an acronym. So everything starts with a user question that you can see on the right in green is embedded using the same embedder that we used before for every chunk of our documentation. And then with this embedding of the query, we perform a so-called similarity search inside the vector database, which is an operation done to retrieve the most semantically similar chunks with respect to our query. And here we retrieve the top k chunks, where k is an hyperparameter that we can set as we need. And hopefully these chunks also contain some information that is useful to answer to the question, since they are the most semantically similar to our question. So we pass the user query and the chunks that we retrieved along with the instruction to form a contextualized prompt, and we pass everything as input to the LLM that is now able to hopefully give us an answer which is grounded using our documentation. So the vector search is not magic, it's just a mathematical operation under the hood, because as you see, we have a question, we embed the question, and then we search inside the vector database for the most semantically similar points. And we do so by just performing an operation like a cosine similarity between vectors. And as you can see on the right, in this case, we are, as an example, retrieving the top 3 chunks. And we were lucky because one of these documents also actually contain some information that can be used to answer the query, which is what are the steps involved in handling purchase requests. So all these chunks are then aggregated together to form a reference for the LLM. Vectoria is not just a matter of code, but we need to involve people. Because first of all, we need to activate the right stakeholders to get the documentation of our company, because everything starts with the documentation. Then we need to study and pre-process the documentation to extract the metadata. If possible, it is not mandatory, but it helps the filtering operation inside our knowledge base that may be also very large. And then the third point, which is the most important, is that we need to get question-answer pairs, so a test set from domain experts to test our system, because since this is AI, but we want to be sure that the system is behaving in the intended manner, and so it's producing the correct answers. And now I leave the floor to Luca, which will explain you how to scale and deploy Vectoria on HPC.
Yeah, I want to further stress this last point that during the development of Vectoria, we didn't use let's say, a standardized evaluation system, but rather we focused on getting some answers and question pairs from actual domain experts within the context that the RAG workflow had to extract information from. And actually in Leonardo, they are actually implementing this system in their own business management system for production use. So, and I will show you a quick showcase on a few test sample answer question pairs that we have performed on 3 different systems. One of the strong points about this workflow is that it is scalable and transferable, meaning that it works from, of course, HPC clusters with lots of GPU memory. And for this test, we have used we employed the Llama family of LLMs. And for the largest one, we used the 70 billion model that fits in a single node of Leonardo. We have also tested smaller systems, one that should fit in any high-end workstation with a single GPU with reasonable amount of memory, so the 8 billion, and as well as, say, trying to break the system also on a laptop CPU, so not even GPU accelerated, with the smallest model available from Llama family, the 1 billion model. As a first test, we created the vector database on HPC, and this was also actually used for all runs, meaning that it is also possible, for example, to use HPC not just for the vector database and inference, but you can also produce the vector database if you have a lot of documentation on HPC using high computing resources, and then transfer that database to a smaller LLM that you can run on a scaled down system. I downloaded the AWS documentation, which is 8 PDF files for about 20,000 pages. Obviously, since it's a pretty famous service, we're not actually sure if this was also part of the training dataset, and we've done a second test to also account for that. And I just asked a couple of questions to see how the model behaves. For some questions, we can actually see that the smaller systems, the smaller models may actually be a bit too limited, but also going from just a regular workstation, we can see that we start to get similar answers and perfectly satisfactory answers. Obviously, the larger model reads a bit more natural and is a bit more conversational, but the content of the the answer was satisfactory for both, and both were able to actually find the correct piece of context for this specific question. Oh, I forgot to mention that for the largest model, we are also employing a re-ranker stage. So after the search for the context relative to the answer in question, there's also a step that is specific to re-ranking the chunks and help produce better ranking on this side. For the second question that I asked, actually the smallest model was able to produce a brief question, but with the correct content for that we needed. Again, as you go higher in dimensions, obviously you get the more accurate and elaborate responses, but this is expected. To see if how it behaves with surely not seen before documentation, I've also compiled a list of some scientific papers taken from the OpenRAG benchmark dataset, which is comprised of about 400 positive documents, meaning that the list of questions that they wrote was linked to one of these specific documents, but also featuring 600 completely unrelated documents to try and distract the pipeline and make some introduce some noise. These are all very recent papers, so it's very unlikely that this was seen during training. So we should have a pretty blank slate to test this this comparison. Once again, the vector database was compiled on HPC, and that file was transferred, was copied to all other machines without needing to rebuild it from scratch. This specific question, we see that the smallest model was actually able to find the correct document because it started to give the correct answer, but it stopped at some point, probably because the capabilities of this model were a bit limited. Still, it's interesting to see that we see that it found the correct document to evaluate, and once again we see that the larger models are able to produce the correct answers. And on this question, we see that actually, despite being able to find the correct document, there is a subtle nuance on the answers that make it so that the smaller models, even the 8 billion, is not quite correct in the answer, while only the largest model was able to appreciate the subtle differences that were necessary for the correct answer. And this is once again the reason why it's very important to have domain expert validate the answers that the models reproduce. And as a third test, we see that sometimes the model is completely incapable of producing basically any answer. It just outputs a point, a dot, while the others have similar answers. So even with a high-end workstation or a small instance in a small cluster, companies should be able to feature a RAG workflow, which is by this nature completely private, because you're not renting any compute time on AWS or some third-party hosts or using a third-party AI. And so companies are able to protect their intellectual properties and data this way. The deployment procedure is very simple and straightforward. We use an Ansible workflow for the deployment, which can be cloned by just downloading the GitHub repository, which you can find at this link. It's completely open and free to download. And you only need to edit 2 files for the deploying procedure. A host file, which just you need to input the IP address or the address of the machine where you want to perform the deployment, and the username to use. Obviously, you should have your machine should have SSH access to this machine. And we condense all the relevant configurations in a single file where you can tell it where to install the Vectoria. Optionally, since during the download of the LLMs, many of them use the Git LFS. Also, if you have some modules that you would like to preload on HPC for the virtual environment of choice, some configuration about the job scripts that will be created by the deployment procedure with account partition, how many CPUs and GPUs you have access to, and some specific alarm settings. So the language in which the documents will be found. Currently, we support Italian and English, and the format, which can be PDF or Word documents. And also, all this configuration can be adjusted at a later time, but for the defaults, you can also tell it to use quantization for both the re-ranking and inference stage. This is possible to do also locally. So if you want to install Vectoria on your local machine, you just have to, in the deploy configuration file, to change the host to your local host, and all the procedure that I will show here also happens locally. For the deployment, you just have to run this single command, and then the Ansible playbook will take care of everything. So loading and reading the configuration that you have provided, creating the necessary directories, either locally or on the remote host that you have indicated, installing the Vectoria code base on HPC in a Python virtual environment that is configured as you have requested. Here it's writing the sample, the template script files that you can use to launch on HPC with pre-made configurations that should be ready to launch as they are, once you just have uploaded the documents that you want to run the your RAG procedure on. And here it's also taking care of downloading the LLM, the embedded, the re-ranker, and the inference engine that you have requested. Just one point of caution, some models like the Llama family of models require you also to register your SSH key on Hugging Face for the download. So as long as you've made sure that you can download these models on your machine, it should be able to automate also this procedure. And after this stage, the system is ready to use. So to reassume on the conclusions, what Vectoria enables the industry to do is to provide a RAG workflow which is fully private and closed. So again, without needing to sign up for ChatGPT or the various Copilot alternatives, everything is used on premise, and the company has the full control on everything that happens. There is nothing leaving the infrastructure. The deployment is very simple, so it's streamlined with Ansible. Just a few commands can get you up and running straight away, also leaving the option to customize a configure for the expert in the sector, all the various scripts that are produced. We have multi-format support for PDF and Words, also for currently English and Italian, two languages. It's highly customizable and scalable, so you can fully scale from personal laptop without a GPU to HPC facilities, and anything in between. So it's very flexible and customizable, and obviously it's fully open source. So all the components and the code base are completely open and free for anyone to utilize and download. Thank you for listening. I don't know if we have time for some Q&A or if it's left at a later time. Of course, for any question, you can reach out to us personally, and we'll be happy to get in contact.
Hi, thank you, Luca and Andrea. Maybe one quick question from Nikos, and then we can have some time at the end of the session to ask more.
Absolutely.
Okay, hi, it's Nikos from NCC Greece. Thank you very much for the very interesting presentation. Okay, I have noted many questions actually because I found the presentation quite interesting, but I understand that we don't have time now. So I will just ask about the vector database, if you have any information about the size and how many vectors you produced, any scaling issues, etc.
Andrea, I don't know if you want.
I noted it was 20,000 pages.
Yes. So, okay, I can say that for the AWS, the index is 400 megabytes for the AWS one was about 430 megabytes for the VectorDB. The other one, since it had few less documents, is like 40 megabytes. So we're in the order of like half a gigabyte for 20,000 pages of PDFs. I don't know how this scales with different documents or formats, but roughly this is the ballpark, let's say.
Okay, okay, I understand. And something very fast. The deployment was on Leonardo. You said that. How the authentication works? I mean, you need to authenticate with you do SSH to when you serve the model.
Yes, the Ansible script is run locally on your machine. If your machine has SSH access to the host that you want to do the deployment on, that's enough. So as long as you have SSH access to Leonardo,
Okay.
you can do the deployment on Leonardo.
Nice, nice. Thank you very much.